Trigonometry is useful. It spits out numbers like magic with seemingly no correlation between inputs. However, the one rule that stood in my mind for the longest time was that trigonometry could only be used on right triangles. So imagine my surprise when introduced to sine and cosine law, laws that exist purely because some guy chucked the alphabet and three-sided polygons into a blender and made a smoothie. Anyways, sine law and cosine law are simple. They are a set of connections between angles and sides of oblique triangles, which are triangles that are not right. These laws come from dividing a triangle into smaller right triangles and then finding the correlations between sine functions of these smaller triangles. There are 2 videos on YouTube that explain this very well, and I've put them in the description. Imagine you had a triangle with angles capital A, B, and C, and the opposite sides to these angles small a, b, and c. Sine law states that the sine of an angle divided by its opposite side is the same as the sine of another angle divided by its opposite side. In other words, sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. In a real problem, you will most likely only use 2 of these. For cosine law, you have the same triangle, but now side A squared equals the sum of the squares of side B and C minus 2 times the product of the side B and C times the cosine of angle A. There are 3 equations for side A, side B, and side C, but really they're just the same equation, but the letters moved around. The letters on the left side of the equal sign is the sign you want to find, and the right side of the equal sign is just the sum of the squares of the other 2 sides minus 2 times the product of the other 2 sides times the cosine of the angle correlating to the side you chose. So b squared equals a squared plus c squared minus 2ac cosine angle b. Let's take a look at this sine law problem. In this problem, we know 2 angles on one side and are asked to find the other side. Using sine law, we know that sine 60 over 7 equals sine 80 over x. Now we just have to solve by cross multiplying, then dividing both sides by sine 60 to isolate x. You can enter the right side into the calculator, and the answer is approximately 7.96. In another problem, side lengths 90, 100, and 50 are given, and you are asked to find angle A. This is a cool use case for cosine law because you can plug in all the side lengths into the equation as A, B, and C and just solve for the angle. In this case, we'll construct the equation 90 squared equals 100 squared plus 50 squared minus 2 times 50 times 100 times cosine A. The key is to put 90 on the left because as you recall, the equation requires that the target angle be opposite to the length on the left. Now, by subtracting then dividing to isolate cosine A, and then isolating A by using inverse cosine, we get the answer of approximately 63.9 degrees. But we're not done. You see, sine law can actually have 2 solutions if one side length is smaller than the other side length and is also larger than the height. In this case, the side length in the question can swing around and form another triangle. In this case, you can see the orange side swing around to form an obtuse triangle. If you were given a word problem that said a triangle had side 10 and 6 and had an angle 33 and were told to find the opposite angle to side 10, then you would have to write both angles. The first one is easy. You just put in an equation, cross multiply, isolate the sign, and then take the inverse. The missing angle here should come out to be approximately 65.19 degrees. To find the second angle, you swing over the arm. There are 2 triangles now, an isosceles triangle and the obtuse triangle we want. And since the two angles of the isosceles triangles are equal, the angle of the obtuse triangle is really just 180 degrees minus 65.19 equals 114.81 degrees. One thing to note is how to identify when to use sine and cosine law. Cosine law is when angles and degrees are not opposite, for example, 2 sides and an angle in the middle. And sine law is used when angles and sides are opposite, forming an X shape, basically. And that's basically sine and cosine law. If I miss anything, yell at me and I'll